So again, we'll be using the first and second derivative to find out all this information, except for asymptotes. Well, vertical asymptotes occur when a function is undefined by division by 0. That doesn't happen in this problem. And then a horizontal or slant asymptote happens if a function gets closer and closer to some line or similar function. But this oscillates up and down, up and down. So this is going to say as you go out sort of along the line of y equal x, then have it go up and down and up and down. So there's not going to be any asymptotes. We just need to do the first derivative and the second derivative stuff. So for the first derivative, it's going to be a 1 plus cosine of x. And then find out any places that that's undefined, which there are none. Next, find out where the derivative equals 0. Or if you move the 1 over, where is cosine of x equal to -1? So let's see, if you take a look at the graph of just cosine, it looks like this for one cycle, and it equals -1 right in the middle. So right there would be 2 pi, right here's pi. And so x equals pi is a critical value. And it doesn't give us any interval over here saying only look between 0 and 2 pi. So in fact, we'd need to find all solutions. Well, the next one is going to be, that's 2 pi, so the next one's going to be at 3 pi. So then the next one's going to be at 5 pi, 7 pi, so odd numbers. So you could say it like this, times n with n odd. And then it could even be negative pi and negative 3 pi, etc. on the other side. Okay, now we need to find out, are there minimums, maximums, where is it increasing and decreasing? So now on the number line, I would have, here's pi, and here's 3 pi. Over here is negative pi. So what's happening to the derivative in between these? Because at all of these I found out the derivative equals 0, so it's possible that there's minimums or maximums there. Well, if you go back to this function, pick something in between. Like for example, if I were to pick something in between here, like 0. Well, cosine of 0 is a 1. Together with that one makes a 2, but the point is that it's positive. So that means it's increasing in here. Okay, now pick something over here like 2 pi. Well, 2 pi is the same thing as saying 0. It's going to be a 1 again, and so it's still 1 plus 1 is 2, but it's positive. And the same thing is just going to keep happening every time. 4 pi would mean do another whole cycle, and you end up, so it turns out that this thing is increasing almost everywhere. So it's increasing from, how could we say this in general? So we've got these n pi's, and then if you go to the next one, so I could say from this, which is 1 pi, to the next one, which is that number plus 2. So from pi times n to pi times n plus 2, where n is odd. But I put round parentheses so it's not actually including these pi's, because that's where the derivative equals 0. It's not increasing. And then decreasing, never. And since it's always going up, it doesn't have a maximum or a minimum. Because in order to have a max, it would need to go up and then down. That would be a maximum. but it never goes down. Okay, next, how about the second derivative? So the second derivative is going to be the derivative of this, which is a 0 minus sine of x. And there's no places where this is undefined, so we just need to find out where is it equal to 0. So multiply both sides by a -1, and it says, when does sine equal 0? Here's the graph of sine for one cycle. There's 2 pi, there's pi, and there's 0. So it's equal to 0 at all of those three. So that means we have possible changes of concavity every multiple of pi. So at 0, over here at -pi, at pi, at 2 pi, this is for the second derivative, and at these places the second derivative equals 0. Then what about in between? So for example, at pi over 2, well that would be right here, pi over 2, and sine is equal to a 1. Then because of this, it's negative. So it's negative in here. And what about at 3 pi over 2? So that would be right here at 3 pi over 2. The function's down here at -1. And if that's -1, that negative will make it positive. So it turns out that it does change concavity. This is concave down, this is concave up. And it's just going to alternate concave down and concave up. So we've got concave up. So that's from, let's see, this is an odd multiple of pi to an even multiple of pi. So I could still use this idea of n being odd, go from pi times n, like this one, 1 times pi, to the very next one. So it's going to be pi times n plus 1. And then again, that's n being odd. And then concave down is going to be from the even ones. So I could say pi, now I want an even number, I'm going to call it m. So an even one, for example, 0 is an even number. So started at an even number times pi to the next one. So an even number to an odd number. So to the next one, where m is even. Okay, so we've got, there are no asymptotes. This function is almost always going up. It does change concavity. And the last thing to do is take a look at the graph. So it's x plus sine of x. So it's going to essentially go up along the line y equals x, but it's not an asymptote because it doesn't get closer and closer to that line. It just waves up and down, up and down, up and down forever. Okay, so it's increasing almost everywhere except at these, for example, at pi and 3 pi. So you could take a look at a couple of those trace, and at pi, so it leveled off just for a second and then kept going. So it's like it goes up, rest, up, rest, up, rest. But that's not a minimum or a maximum, because on that side it would be considered a maximum, and on that side it's considered a minimum, so it's neither. And then as far as concave up and concave down, if we look, for example, from 0 to pi, so 0 from there to pi, yep, that is concave down, and then it switches to concave up, and then switches to concave down, etc. So I think we have this one done.